This is the Applied Math 5.1 through 5.4 review for the quiz. So I'm going to do the odds on this one. So if we look at that first one, number one, we should always remember that anything raised to the 0 power is always going to be 1. So that's just a beginning one. All right, in number 3, what we don't like is that there's a negative exponent. And since this negative exponent is attached to 5, we're going to bring it up. Now then what happens there is a 1 is left on the bottom just because there's nothing left there. And it will be on the top, it'd be 5 times 5 to the second. So we would then do, that would simplify to 5 times 5 to the second is 25. And if you wanted to, you can keep that over the 1, but you don't have to. So then 5 times 25 would then be 125. And that's your final answer. So if it was over 1, you would just then say 125. All right, number 5. All right, so number 5, remember, this is the tricky part with the exponents. This exponent is for this 5, so it's attached to that 5. Remember, there's a negative 1 in front of that negative sign. So what I'm going to do is I'm going to take all of this, and then if this is over 1, I'm just going to put it on the bottom. So then what that's going to do is on the bottom, it's going to be a 5 to the second power, and then remember what's still left on top is a negative 1. So then I can further simplify by doing a negative 1 over 5 to the second power is 25. So your final answer would be negative 1 over 25. Number 7. This one's a little tricky here. Remember, this exponent is attached to 11, not to the negative. So what that means is it's kind of like saying negative 1 times 11 to the 0. So 11 to the 0 is going to equal 1, and then this is a negative 1 times 1. So your final answer is going to be negative 1. All right, and then let's take a look at number 9. So in number 9, again, the exponent 0 is for the p, and then also for the 15. Now, since it's 0, it's going to be, if I rewrote it, it'd be like this. It'd be negative parentheses 15 to the 0, p to the 0. And then we remember that anything raised to 0 is 1. So it'd be like saying 1 times 1. And then if we further go ahead with our calculation, it would be 1 negative parentheses 1 parentheses, and then our very final answer, so that'd be like saying, this would then be like saying negative 1 on the outside times a positive 1 would be a negative 1. All right. So number 11, first thing we can do right away is I see that y over 0, or y to the 0, that's going to be equal to 1. So I'll just cross that off right away. So what I'm left with is 4x to the negative 3. Now what I don't like again is that negative exponent, and it's attached to the x. So if this whole thing was over 1, I want to bring this down. So that would be remaining 4 on top, and then an x to the positive third on the top. All right, 13. It looks like a lot. Let's just take it one step at a time, all right? What we want to do is, we don't like that there's an a to the negative 2 there, right? So what we need to do is get rid of that sucker. Then we also don't like that there's a d to the negative 4, so we gotta get rid of that. So the a to the negative 2 is going to go on the bottom, and the d to the negative 4 is going to go on the top. So what that looks like then is negative 6, and then this square is going to go to both of these. So then it'll be b squared c squared. And then remember the d to the negative 4th right here is going to the top. So it'll be d to the positive 4. And then that will be over what we wanted to put on the bottom was that a squared. And that is your final answer. All right, 15. Let's keep in mind that there's a negative right there. So it's like a negative 1 times everything that's in here. And then that's all of these are going to be raised before we can do that. All of these are going to be raised to the negative 2 power. So it's kind of like if we rewrote it, it'd be negative parentheses 6 to the negative 2, y to the negative 2, z to the negative 2, parentheses, x to the 0. Now x to the 0 is going to equal 1, so I'm just going to get rid of it. And then, if this thing is over 1, what I want to do is I need to get rid of everything that's got a negative exponent. So I'm going to get rid of this, I'm going to move this, and I'm going to move this. So I'll be left on top. Keep in mind, there's this positive here. I'm sorry, there's that negative there. So on the top, because nothing's going to be left, it would just be negative 1. Okay, keep that in mind. If there's nothing there, that just means there's a negative 1. And on the bottom, 6 to the second would be 36. And then we would just have y squared, z squared. All right, same thing with 17. It's a little bit trickier, but we're going to do the same things we did before. What we don't like is the negative exponents here. And then this negative to the negative 3 on the bottom goes to the u and the v. So if I rewrote that, it would be 6t to the negative 1 over 11 u to the negative 3rd, v to the negative 3rd, w to the 4th. So, just like we did before, I want to get rid of this. It's going to go on the bottom. And then anything with a negative exponent on the bottom is going to be going to the top. So after I do that, I will have 6, because that stays. And then I will have u to the 3rd, v to the 3rd, and then on the bottom, I'm going to keep my 11. And what's left down there is w to the 4th, but then remember, we're still bringing this t down. W to the 4th, t to the 1st. That's number 17. All right. Let's make sure I have. So I got everything on there. All right, so evaluate each expression. So evaluate, that's the key word. All we're doing is plugging in. So this is z to the negative 3rd. I go up here and I look, z to the equals 2. So that'd be 2 to the negative 3rd. I don't like that negative. So what I'm going to do is, if this is over 1, I'm going to bring this whole thing down. So I'll have nothing remaining on the top. So there's just a 1 there. And then that'll be 2 to the third. And then I can do 2 to the third. So that's 2 times 2, which is 4, times 2, which is 8. So 1 over 8. (21) is 6x, well, not x, 6 times negative 2 to the third times negative 2 to the 0. So, as you can see, there are no negative exponents, so we don't have to move anything. Negative 2 to the 0, any number to 0 is going to be 1. So what I'm left with is this right here, 6 times negative 2 to the third. So that's negative 2 times negative 2 times negative 2. So negative 2 times negative 2 is a positive 4, times 2 times negative 2 is a negative 8. So that'd be 6 times negative 8. And what I'm left with there, because I can do that, would be negative 48. All right, 23. So we can simplify this first, because this one's a bit of a tricky one, okay? Give me 1 second. So this x to the negative 2, if this is over 1, we're going to bring that to the bottom. And what you're going to be left with is a negative 1 on top, and then just x squared. So then I can evaluate x is equal to negative 2. So that would be like negative 1 over negative 2 squared. So then that would equal negative 1 over, and then negative 2 times negative 2 is 4. So your final answer is going to be negative 1 over 4. (25), we're looking at population of a suburb is 4,000 people. The population of the suburb is expected to double each decade. The expression 4,000 times 2 to the d models the population of the suburb for each decade. Evaluate, which means plug in, the expression for d equals negative 2. Describe what the value of the expression represents. So, evaluate, so all we got to do is plug in negative 2 for d. So it's going to be 4,000 times 2 to the negative second. Now we don't like that has a negative, so that's then going to equal 4,000 over 2 to the positive 2, which is then equal to 4,000 over 4, because 2 squared is 4, and then 4,000 divided by 4 is 1,000. So we found out what happens to what the population would be. Okay, if the expression for negative 2 describe what the value of the expression represents in this situation. So this would say that 1,000 people, it would be 1,000 people two decades ago. Because a little bit tricky, but if D is representative of how many people, like what the decades are, having a negative 2 would be like saying going back 2 decades. So 1,000 people 2 decades ago. Now, if, for example, I said d was equal to 4, and I plugged that in and found the answer, that would be like saying that would be like saying 4 decades into the future. But since we have a negative number, it's 2 decades into the past. All right. All right, so we're just going to evaluate, plug in. So if x equals 5, I'm just going to put x right here. Now remember, f of x, that just means the function of x. So don't get tripped up on that. Literally, cross it out. All right? You can just rewrite it as y equals 2 times 3, and then we're going to plug that in to the fifth. Okay? Then we would just do 3 to the fifth, which I don't know off the top of my head. So 3 times 3 is 9 times 3. Yeah, that's too big for Mr. V. So I'm going to do on my calculator 3 to the fifth is equal to 243. So y is equal to 2 times 243. And I'll get 486. Okay, so if you wanted to, you could just circle this right here, or you could rewrite it in saying f of x is equal to 486. So either one of those two circled would be fine. All right, we're still evaluating. It's x to the 0. It's already in y equals, so y equals 5 times 7, and then I'm just going to plug in 0 for x. 7 to the 0 is just 1, so it's like saying y is equal to 5 times 1. So y is going to be equal to 5. All right, 31. The library City Hall will be increasing the number of books it has to loan at a rate of 5% per year. The library currently has 40,000 books. The number of books they will have in any given year is modeled by the function. The function of t is equal to 40,000 times 1.05 to the t power, where t is the number of years. How many books will the library have in 8 years? So this is a word problem, but don't get too confused. All it's asking you to do is take this and plug it in for t. That's it. So what you would have is 4,000 times 1.05 to the 8th power. Okay, and that's just calculator work. So what I would do is I would do the 1.05 to the 8th. If I'm doing this step by step, but you could just plug this into your calculator. But I'm going to do 1.05 to the 8th power. I get a big number. It's 1.477455, yada, yada, yada. I'm going to take that and multiply that by 40,000. There should be another 0 in there. 40,000. And that's going to equal 59,098. So 59,098, and then remember, books. That's how many books it will have in 8 years, according to that model. All right, now we're on the graphing. Remember, these are just basic math, or generic math, okay? That's it. So the numbers we're going to use are going to be -2, -1, 0, 1, and 2, and 3, okay? If it was a real-life word problem, we would use 1 through 5, but we're not doing that. This is just a regular, computer-generated word, or a math problem, not a word problem that's real life. So we're going to use -2 to 3, and all we're going to do is plug -2 in for each one of these. So this would be 3 times negative 1.5 to the negative second power. So instead of writing all this out, Mr. Class is letting you just literally plug it into your calculator. So for, let's see here. So for the first one, I'm going to do 1.5 to the negative second. Hold on one second. I'm using a different calculator. So an easy way to do this would just be like, you know that this is 3 times 1.5 to the negative second, and you could just bring this down. So then what you could do is just 3 divided by 1.5 to the second. So if I just did 1.5 squared, that'd be 2.25. So 3 divided by 2.25. Is equal to negative 0.95. And I might have that one wrong. Let's just see here. Oh, I think I do it. Let me see. Let me just redo it. Alright, so I'm going to do 3 to the sorry, I'm going to do 1.5 to the Alright, so I went and got an actual calculator that I can use. So, sorry about that. So what I'm going to do is, so you could just plug this into your calculator. So if I just did 3 times 1.5 to the negative second power, I would get 1.33 or 1.34. It's 1.3 repeating, so we would just do, you could do 1.34, you could do 1.4 if you wanted to. Both of those would be fine. So I'm going to do the same thing with negative 1. I'm going to do 3 times 1.5 to the negative first power, and that's going to be 2. And then I'm going to do 0, so that'll be like 3. So remember, 0 to the 0 power is going to be like 3 times 1, because this is going to turn out to be 1. So 3 times 1 is 3. Then 1.5 to the first power is going to be 1, so that'd be just 3 times 1.5. It's going to be 4.5. Oh, wrong button. Sorry, 4.5. And then to the second, so 3 times 1.5 to the second power is going to equal 6.75. And then our last one, 3 times 1.5 to the third power is going to be 10.12. Oh, sorry, 10.13, but that's not really going to matter when it comes to graphing. All right, so now we go to graph this thing, and we're just going to have to do our best. So I'm -2, so I'm going to go to the left 2, and I'm going to go up 1.3, so probably about right there. Second one is -1, 2, so -1, and then right on the -2, and then I'm going to go 0, and then up 3, and then 1, 4.5, and then 2, 6.75, and then 3, 1, 2, 3, and then 1, 2, 3, 4, 10, little above 10, that right there, and those are our points. Now from here, it's hard for me to do so on this, but just bear with me. You would just then draw a line. You want to draw like a line that goes through all of them like that. Even though you can't really see my red points, it'd be much easier with a pencil, but it'd be something like that. All right, so that's that one. 35, what I'm going to do, just so this video isn't too long, is just remember XY chart. And we're going to do -2 through 3. So -2, -1, 0, 1, 2. We're going to do the same thing we just did, just calculator work. Plug in 3 times 0.75 to the -2nd, and then write that here. Then we graph it, and for 35, what our graph is going to look like is something like this. So make sure your graph looks something like that. All right, so tell whether the exponential function show exponential growth or decay in y, then state what the growth factor is tell what the growth factor of the decay factor is. So for number 37, y equals 250 times 0.1065 to the x, our growth factor is going to be this number right here. So 1.065, okay? And then it's state whether it's growing or decaying. And we're going to say it's growing. And that is because our growth factor is greater than 1. Let's do the same thing over here. 1.02 is going to be our growth factor. So that's going to show growth. Same reason as this one right here, because the growth factor is greater than 1. Then we're going to go over here. So our growth factor is equal to 0.1. So it's decreasing. Or in other words, what you should write is decay. Because the growth factor is less than 1. So those are pretty easy to run through. All right, so find the balance. So this is our compound interest. So we need to know our equation. So A equals P1 plus our rate over the number of times it's hit to the n times t period, or n times t exponent. So what I do is I need to find P, R, N, and T. So we know that $2,000 is our P, that's our initial deposit. It's 6.8%, so our rate, we're going to move that over to make it a number, or a decimal, not a percentage. It's going to be 0.068. It's compounded daily. How many days are there in a year? There's 365 days in a year. And then the time is 3. So I'm going to take all these numbers and just plug them into that equation right there. So it'll look like 2,000 times 1 plus my rate of 0.068 over the number of times it's hit, which is 365, and then to the n times t, which would be 365 times 3. Now, you can simplify what's in here, and then you can simplify what's in here if you don't just want to plug this into your calculator. You could just plug this in your calculator and that would be fine, but you would need to at least show this step right here. So what I'm going to do is I'm going to do 2,000, and then I'm going to do what's on the inside the parentheses. So I'm going to do 0.068 divided by 365 is equal to a very long decimal, and then plus 1 is equal to another very long decimal. So this one actually might be better suited for a calculator work. So I get like 1.00018630137, okay? And what I can do there, I mean, I could just write it in there, 1.00018630137. And then I got to do this, 365 times 3. So 365 times 3 is equal to 1095. So then from there, I got to take this and raise this really long decimal to that power. Or I could just plug this all in. So I'm going to just plug it all in. I get 2,000. Oh, I did 20,000. So 2,000. Parentheses 1 plus 0.068 divided by 365, and then I'm going to do parentheses, and then I got to raise that to 1095. And then that's going to give me my final answer of 2,452, so $2,542, and then it's gonna be 55 cents because we got to round because it's money. Make sure we label it, and that's your final answer. So if you deposited $2,000 in this scenario and you earned 6.8%, it was compounded daily for 3 years, you would go from $2,000 to $2,452.55. So you would earn some money from compound interest. All right, same thing with 45. Let's see how many we got left here. So this is the last one here. 45. So I know my P is 3,500. It's 3.65%. So I'm going to move the decimal over 2 spots. 0.0365. Now it's quarterly. How many quarters are there in a year? Think about how many quarters are there in a dollar. So there's going to be 4. So that's how many times the compound interest hits the amount you deposited. And then a time of 2 years. So if I write that, it's going to be A is equal to my initial deposit of $3,500 times 1 plus R, which is 4, over N, which is 2, and then N times T, which is 2 times 4. So you could simplify this really easily just by doing 3,500, and then 4 divided by 2 is 2, right? And then plus 1, so that'd be 3. Then 2 times 4 is 8. So from here, you could just plug that in your calculator, but what I could also do is just do 3 to the 8th power, and 3 to the 8th power is equal to 6,561. So that'd be 3,500 times 6,561. And that would be a really long number that I think I did wrong. What did I do wrong here? Because I got in the millions, and I don't think that's right. So let's see what we did wrong. So what I'm going to do is I'm going to start from the very beginning. Okay? Let's just check our numbers. So 3,500, our rate is 0.0365, so that's right. Then at times it's compounded is quarterly, there's 4 quarters, and it's 2 years. So let's see if I just did some math wrong or what's going on. So it's going to be 3,500. And then we're going to multiply that 1 plus my r over n. Oh, that's what I did wrong. I did point. I put the number over the n over the t when I should have done the r over the n. So that'd be 0.0365. And then I'm going to put that over n, which would be 4. I'm going to raise that to the n times t, which would be 2 times 4. So I would probably suggest that you do this one, just plug this one right in your calculator, but make sure that you show this work right here. And if I plug that into my calculator, I'm going to do 3,500, parentheses, 1 plus 0.0365 divided by 4, parentheses, and then I can just do that in my head. 2 to the times 4 is 8. So that's going to be to the 8th power. And what I get is $3,763.81. Okay? So learn from my mistake. I looked at this problem and I got this number in the millions and I knew I did something wrong. So I erased everything and I rechecked my numbers up here and then plugged them back into this equation right here. And I realized I had gotten it wrong right there. And I put the wrong number, which threw the whole equation off. Okay? So, quiz is coming up. Make sure you email me if you have any questions. And let me know if you need anything. And I'll be available checking my email a couple times a day. All right, thanks a lot. Bye.